Hello everyone, this is Abhishek Mohanty and welcome to lecture number 12 of the chapter Electric Charge and Field. Students, in this lecture we will solve few numericals based on the concept of Coulomb's law, electric field and electric field lines and continuous charge distribution. So let's get started. So students, look at the first question. The question is calculate the total force acting on the charge plus Q placed on the x-axis. So you can see that in the figure, this is the x-axis and this is the y-axis, and we have three identical charges, each having magnitude capital Q, and these three charges are placed at the three different points A, B and C. And you can see that point A and point B, they lie on the y-axis, point C lies on the x-axis, and the distance of the point A, point B and point C from the origin O are equal. This OA is equal to capital R, OB is equal to capital R and OC is equal to capital R. So in the question we have to find the net force, means the net electrostatic force on this charge, the charge which is placed on the x-axis. So students, we know that according to the superposition principle of Coulomb's force, whenever we have more than two charged particles interacting with each other, then to calculate the resultant force on a given charge, we have to first calculate what are the different forces acting on it, and then we have to add all the forces vectorially to find the resultant force. So in this system we have three charges, and this charge plus Q will experience force due to this charge as well as due to this charge, means there will be two forces acting on this charge Q. So let us join the point A with C and the point B with C. This angle is 90 degree, this angle is also 90 degree, and OA and OC, they are equal, so these two angles are also same, these are 45 and 45. Similarly, in this triangle, this is 45 and this is 45. So you can see that the angle ACB is 90 degree. Is that clear? And what will be the value of AC? The value of AC will be R into root 2. If you apply the Pythagoras theorem, then in this triangle AOC, this is the hypotenuse, AC is the hypotenuse, then AC square will be R square plus R square, means 2R square. So AC will be root 2 into R, or I can write R root 2. Similarly, BC is also R root 2. Is that clear? So since all these charges are positive charges, so the force on this charge due to this charge will be repulsive. It means the charge at A will repel the charge at C, and the repulsive force will be along this direction. This is F1 vector. Is that clear? This is F1 vector. Similarly, the charge at B will repel the charge at C, and if that force is F2, then F2 vector will be along this direction. This is F1 vector and this is F2 vector. So let us write the expressions for F1 and F2. So F1 vector will be how much? It will be K means the Coulomb's constant, into Q1 into Q2, means Q into Q, divided by the distance square, means AC square. So what is AC? AC is R root 2, so AC square will be 2R square, and its direction is along AC. The direction will be along AC. And what will be the expression for F2 vector? F2 vector will be K into Q by 2R square, and this direction of F2 will be along BC. So write along BC here. So you can see that F1 magnitude and F2 magnitude are equal. The magnitude of these two forces are same, and what is the magnitude? it is k into q square by 2r square. The magnitude will be k q square divided by 2r square. So we have found the two forces acting on the charge at C, and to find the resultant force we have to add them vectorially, and for that we must know what is the angle between them. So the angle between F1 vector and F2 vector is same as this angle, because this angle and this angle, they are opposite angle. This is 90 degree, so this one is also 90 degree. Is that clear? So F1 vector and F2 vector, they are perpendicular to each other. In class 11 we have discussed that if we have two vectors A and B, and if they are perpendicular to each other, then the magnitude of the resultant vector is given by r equal to square root of a square plus b square. Similarly, here the resultant force will be how much? Square root of f1 square plus f2 square. But you can see that f1 and f2, they are equal, their magnitudes are equal. So I can write f1 square plus f1 square, because f2 is equal to f1. This is equal to 2f1 square square root, that is equal to root 2 into f1, that is equal to root 2 into, what is f1? f1 is this much, k q square divided by 2r square, that is equal to root 2. In place of k you can write 1 by 4 pi epsilon naught, then you have q square by 2r square. This is equal to root 2 into q square divided by 8 pi epsilon naught r square. So this is the expression for the total force or the resultant force acting on the charge which is placed at C. So in this way we can solve this question, and now we'll proceed to the next one. So now look at the question number 2. The question is, the linear charge density of a half ring, means a semicircular ring, varies with theta as lambda equal to lambda naught cos theta, and here this lambda naught is a constant quantity. So you have to find what is the total charge on the ring. There are 4 options given and you have to choose the right option. So look at the diagram here. We have a semicircular ring, and suppose the radius of the semicircle or the half ring is capital R, and we have some charge distributed over the entire semicircle, but the distribution of charge is not uniform, because the linear charge density lambda is not uniform. This lambda varies with the angle theta. And what is theta? Theta is the angle between the position vector of any point on the ring with x-axis. Suppose this is the x-axis, and if you choose a point here, then the position vector of this point will be this vector. Join that point with the center O. This one will be the position vector. If the position vector makes an angle theta with x-axis, then at that point the linear charge density will be how much? Lambda equal to lambda naught cos theta. So if you choose different points on the half ring, then the value of theta will be different. And if the value of theta will be different, then the value of lambda will also be different. It means lambda varies with the angle theta. Okay, and we have to find what is the total charge on the ring. So let us see how to solve this type of question. So this is the case of a continuous charge distribution, and we have to calculate what is the total charge on the semicircular ring. So students, let us choose a very small element. Let us choose a very small element on the ring. This is one end of the ring and this is the other end. Now join this end with the origin or with the center. Suppose R is the radius, and suppose this angle is theta. Is that clear? The angle is theta. Now if I join this other end of the element with the center, then I will get another line like this. So let me redraw this line here. Now I will join this end with the point O like this. Okay, like this. So actually in this figure you can see that the length of the element is slightly more, but in actual practice the length of the element or the thickness of the element should be very small, so that this angle is very negligible. And suppose this angle is d theta. Suppose this angle is d theta. So if d theta is very small, means if the thickness of the element is very small, we can assume that the linear charge density is almost same at every point on this element. The linear charge density is almost same at every point on this element, and that's why we have chosen a very small element. So tell me, what will be the thickness of this element? The thickness of the element will be r into d theta. This is the arc length, this is the radius, and this is the angle. So r into d theta will be equal to the thickness of the element. So at every point on this element, the linear charge density is how much? Lambda naught cos theta, because the position vector of the element makes an angle theta with the x-axis. Is that clear? So the linear charge density will be lambda naught into cos theta. Now tell me, what will be the amount of charge present on the element? Amount of charge present on the element will be how much? dq is equal to lambda into r d theta. Linear charge density into the thickness of the element. And what is lambda? Lambda is lambda naught cos theta, and then we have to multiply r d theta. That is equal to lambda naught into r cos theta d theta. Is that clear? Now we have to find what is the total charge on the semicircle. Total charge on the half ring or on the semicircular ring will be how much? Q is equal to integration of dq from 0 to q. Integration of dq from 0 to q, and that is equal to, in place of dq you can put this value lambda naught into r cos theta d theta, and you can take these two terms outside because they are constant quantities. And what will be the limit of theta here? So you can choose the element starting from this point up to this point. So when you choose the element here, then this line will coincide with the x-axis, so the angle will be 0, and gradually if you change the element position, then finally the element can be chosen up to this point. So the angle theta will vary from 0 to pi, so the limit is 0 to pi. That is equal to lambda naught into r. Integration of cos theta d theta is sin theta, and you have to put the limit 0 to pi. So lambda naught into r sin pi minus sin 0, and we know that sin pi is 0, sin 0 is also 0, so it will be lambda naught into r into 0, that is equal to 0. Means the total charge on the ring will be 0. So option number 2 is the correct option. So in this way you can solve this question. And now we'll proceed to the next one. So now look at question number 3. The question is, if the linear charge density of a wire of length capital L depends on distance x from one end as lambda equal to lambda naught x by L, then find the total charge on the wire or on the rod. So look at the diagram here. We have a rod or we have a wire of length L. This is the left end and this is the right end, and suppose the left end is placed at the origin. Okay, and again on this rod we have some charge, but the charge is not distributed uniformly, and that's why the linear charge density is not constant. Rather, it depends on the position x from one end. Suppose from this end. It means if you choose a point here at a distance x from the point O, then the linear charge density will be given by lambda naught x by L. Lambda naught is a constant quantity. So if you choose different points at different distances from the point O, x will be different, and that's why lambda will be different. And here we have to find what is the total charge on the wire. So we have to solve this question like the previous one, and again you have got the 4 options, you have to choose the correct one. Again, let us solve this question. So we have to choose a small element. We have to choose a small element of thickness dx at a distance x from the end O. Okay, so what is the linear charge density at this location? The linear charge density is equal to lambda naught x by L. Is that clear? And since the thickness is very small, we have considered a very small element. The thickness is very small, so we can assume that at every point on the element, the linear charge density is almost constant. So what will be the total charge on the element? The charge on the element, will be how much? dq is equal to lambda into dx, the linear charge density into the thickness of the element. And what is lambda? Lambda is lambda naught x by L, and then multiply dx. Okay, so this is the small amount of charge placed or available on the element dx. But we have to find what is the total charge on the entire rod. So the total charge q will be integration of dq from 0 to q, that is equal to integration of lambda naught x by L into dx, and here the limit of x will be from 0 to L, so you can take this lambda naught by L outside, lambda naught by L integration of x dx 0 to L, that is equal to lambda naught by L into x square by 2, the limits are from 0 to L, that is equal to lambda naught by L into L square by 2 minus 0 square by 2, and L square by 2, 0 square by 2 is 0, so you have only lambda naught by L into L square by 2. So the answer will be lambda naught into L by 2. So the option number 2 is the correct one. So in this way you can solve this question, and now we'll proceed to the next one. So now look at the question number 4. The question is, a rod of length capital L has a total charge capital Q distributed uniformly along its length, and it is bent in the shape of a semicircle. Find the magnitude of electric field intensity at the center of curvature of the semicircle. And here you have 4 options, you have to choose the correct one. So according to the question, we have a rod whose length is L. The length of the rod is L, and on this rod a charge Q is uniformly distributed. So this is the case of uniform charge distribution. In question number 2 and 3 we had non-uniform charge distribution, but here we have uniform charge distribution. The total charge is capital Q and the total length of the rod is L. So the linear charge density will be how much? Q by L, total charge by total length. Now this rod is bent in the shape of a semicircle. Means I will bend this rod to a semicircular shape like this, to a semicircular shape. And we have to find what is the magnitude of electric field intensity at the center of curvature of the semicircle. Suppose this is the semicircle like this, and this is the center of curvature. We have to find the electric field intensity due to this semicircular wire at this point. Suppose this is point O. So draw a line like this. This is x-axis, and suppose this is the y-axis. Okay, we have to find the total electric field intensity at this point. So let us solve this question. So students, if L is the length of the wire and the wire is bent in the form of a semicircle, so this length is also L. Means this is the half of circumference. If R is the radius, if R is the radius of the semicircle, then its circumference will be pi into R. It means pi into R is equal to the length of the rod, or I can write R equal to L by pi. R equal to L by pi. Is that clear? So the charge is uniformly distributed over the entire rod or entire wire. Means lambda is same at every point. Now let us choose a small element here. Let us choose a small element here. If you join this end of the element with the point O, suppose the angle is theta. Suppose we will consider a small element whose position vector makes an angle theta with the x-axis. And if you join the other point, then suppose this small angle is how much? Suppose this small angle is d theta. The small angle is d theta. Then this thickness will be how much? R into d theta. This thickness will be R into d theta. So what is the charge on the element? Charge on the element will be dq is equal to R into d theta multiplied by lambda. The linear charge density multiplied by the thickness of the element, or you can write lambda into R into d theta. Is that clear? And since this is a very small element, it will behave as a point charge. Is that clear? And suppose assume that it is positively charged. The rod is positively charged. So due to this charge dq, or the charge lambda R d theta, the electric field at point O will be away from that element, because we know that the electric field due to a positive charge is always away from it. So due to this element, the electric field due to this element will be along this direction. Is that clear? Suppose this is dE1 vector. This is dE1 vector. Now tell me what will be the expression for dE1 vector? The expression for dE1 vector will be K, means the Coulomb's constant, into charge on the element, which is this much, lambda R d theta divided by distance square. The distance is the radius, r square. Is that clear? K into lambda R d theta divided by r square, and its direction is in this direction. Okay, now we will choose another element on the other half of the semicircle. I will choose a second element somewhere here. So if you join this point, this end of the element with the center O, then suppose this angle is also theta. This angle and this angle are same. And if you join this point, let us say this angle is d theta. Means we will choose two identical elements on both sides of the y-axis. These are two identical elements. Then the thickness of this element is also r d theta, and it will carry the charge lambda r d theta. And again, the electric field due to this point charge will be directed in this direction. This is dE2 vector. So dE1 vector is the electric field due to this element, and dE2 vector is the electric field due to this element. Is that clear? Now let us resolve these two electric fields. If this angle is theta, then this angle will be theta, and if this angle is theta, then this angle will be theta, because they are opposite angles. Now if you resolve dE1 vector, you will get dE1 cos theta towards left, dE1 sin theta in the vertically downward direction. Similarly, if you resolve dE2 vector, you will get dE2 cos theta towards right and dE2 sin theta in the vertically downward direction. So dE1 and dE2, they have the same magnitude, because if you write the magnitude of dE2, then it will be the same, k into lambda r d theta divided by r square. So dE1 and dE2 both have the same magnitude. Is that clear? That's why dE1 cos theta and dE2 cos theta, these two components will cancel each other, because they have the same magnitude but opposite direction. But dE1 sin theta and dE2 sin theta, they will be added up because they are in the same direction. So for these two elements, the total electric field at this point O will be how much? dE1 sin theta plus dE2 sin theta, that is equal to dE1 sin theta plus dE1 sin theta, because dE2 is same as dE1, that is equal to 2 dE1 sin theta, that is equal to 2 into dE1 is this much, k lambda r d theta divided by r square into sin theta. So r square will cancel, so you will get how much? 2 into k lambda divided by r into sin theta d theta, 2k lambda divided by r into sin theta d theta. And now we have to find the total electric field. So the total electric field E is equal to integration of this quantity. So here this 2k lambda by r is a constant quantity, so I can take it outside the integration symbol, 2k lambda by r integration of sin theta d theta. Since I have chosen two elements simultaneously from both half of the semicircle, so the limit will be from 0 to pi by 2. If I will choose only one element, then these two will be absent, and in that case the limit will be from 0 to pi. But since right now I have chosen two elements from both halves, so I'll only put the limit from one half, because here 2 is already multiplied. The limit will be from 0 to pi by 2, from 0 to pi by 2, from 0 to pi by 2. Is that clear? So what is the expression for E? E equal to 2 into k is 1 by 4 pi epsilon naught. Lambda is how much? Lambda is q by L, and here we have r, so write r here, and integration of sin theta d theta will be minus cos theta, and the limits are 0 to pi by 2. Okay, so take this minus sign outside, you will get minus, here you will get 2 here, so minus q divided by 2 pi epsilon naught. What is r? R is L by pi, so write L by pi here into L, and cos, here we have cos theta, the limits are 0 to pi by 2, so it will be cos pi by 2 minus cos 0, cos pi by 2 minus cos 0. Okay, so this will be equal to how much? Here pi and pi will cancel, so you get minus q divided by 2 epsilon naught L square cos pi by 2 is 0, minus cos 0 is 1. So 0 minus 1 will be minus 1, minus 1 into minus q will be plus q. So the answer will be q by 2 epsilon naught L square. Q by 2 epsilon naught L square. So the first option is the correct one. So students, in this way you can solve this question. And now we'll proceed to the next and the last question. Now look at the last question, the question number 5. The question is, the dielectric constant of pure water is 81. Then its permittivity will be dash. So we have 4 options and we have to choose the correct one. So students, what is the meaning of dielectric constant? Dielectric constant is same as the relative permittivity. Dielectric constant is same as the relative permittivity. Relative permittivity of a medium. And relative permittivity is given by the symbol epsilon r. And what is epsilon r? This is equal to epsilon by epsilon naught. It means the relative permittivity or dielectric constant of a given medium is equal to the ratio of the absolute permittivity of that medium to the absolute permittivity of free space. So if the dielectric constant of water is 81, it means epsilon r is equal to 81. And we have to find what is the value of epsilon. Epsilon is the absolute permittivity of that medium. Means in this case the permittivity of water. So epsilon will be how much? Epsilon naught into epsilon r. So epsilon naught is 8.854 into 10 to the power minus 12 and epsilon r is given as 81. So if you multiply, then you will get this answer, 7.17 into 10 to the power minus 11. So in this way you can solve this question. So students, today in this lecture we have discussed about 5 important questions, and I will bring such numerical sessions in the upcoming classes. So hopefully you have understood all the 5 questions clearly. If you have any doubt, then you can ask me in the comment section, and in the next class we will come with some more numericals. So till then, have a nice day and bye bye.